Hello there, this is Ms. Nakayama, and today's lesson is 5.1, Verifying Trigonometric Identities. This happens to be one of my most favorite things to do, so I hope y'all enjoy it just as much. We have one objective: use the fundamental trigonometric identities to verify identities. So what tools do we have to do that? Most of which you already know. The first group of identities you should be familiar with is the reciprocal identities. Okay, you know that sine and cosecant are reciprocals, cosine and secant, tangent and cotangent. And what you want to remember in these identities is when you multiply sine and cosecant, a reciprocal times its a number times its reciprocal is always equal to 1. So any two reciprocals multiplied together is going to give you 1. The other group, or the next group we have, is the quotient identities. You already know tangent sine over cosine, cotangent is cosine over sine. Then we have the Pythagorean identities, okay? And this one here, y'all, if you remember from our unit circle, okay, we learned our unit circle was x squared plus y squared equals 1. And if x squared plus y squared equals 1, x on the unit circle represents the cosine, and y represents the sine. So if you just make that simple substitution, you have this first Pythagorean identity. Now, how do you get these other two? I struggled to remember these other two because I didn't understand where they came from. So I'm going to attempt to show you. If I take one of these and let's just say, okay, I'm going to divide by cosine. So if I divide by cosine squared, and cosine squared, I'm dividing everything by cosine squared. Well, sine squared over cosine squared equals tangent squared. That's right there. Cosine over cosine squared is 1, and 1 over cosine is secant. So this is the result that you get when you divide the original one by the cosine squared. Well, what if I go and divide each of those by sine squared? So if I divide sine squared by sine squared equals 1. Cosine squared divided by sine squared equals cotangent squared. And 1 over sine squared equals cosecant squared. And that's this guy right here. So I'm pointing this out to you to let you know that you really only have to know this one if you know how to get these other two, and that's just dividing by either sine squared or cosine squared. So hope that helps. The next one, we have even and odd. Y'all, we've been talking about this for so long. I hope that it's easy for you. But the one that we've talked about that we keep going over is the fact that the cosine and the secant are the only two that are even. And that means that when you take the cosine of a negative angle, it's equal to the cosine of that positive angle. That negative sign goes away. And the other four, it goes out front. So you got to remember that. So what are we doing? We're going to verify identities. We have to show that one side can be simplified so that it's identical to the other side. You start with one, usually the more complicated expression, and use those identities to do that. Now, this before in the past, y'all, you had to do this all by hand, and a lot of people struggled with it. I promise you it is so much easier in MyLab Math because they give you the directions somewhat in a multiple choice form to make it easy for you. So look at this first example. I got 5 to do. So we have to verify the identity, and they go ahead and show you which side we're working down. So you don't have to pick. It's not by hand. But this right here is going to be a multiple choice. So you're going to click on the box, and this is where I would encourage you to start. Click on the box, and decide which of these fits. And in this case, it's to rewrite the terms rewrite this in terms of sine and cosine. So cosecant is, of course, 1 over the sine, and tangent is sine over cosine. Notice it says rewrite it in terms of sine and cosine, not the reciprocals. Okay, the next step, divide the numerator and the denominator by the common factor. So what is my common factor here? Well, I clearly have a sine on the top and the bottom. So Cancel out my sine on the top and bottom. That leaves me with 1 over cosine. And then it says apply a reciprocal identity. Then the identity is verified. More importantly, y'all, the last step here is always whatever the other side is. And you have to make it look like that. So it's the secant of x because we know that the reciprocal of the cosine is the secant. If I see cosine on the bottom, I can write it as secant on the top. Okay? That was a simple one. Here's another one that's relatively simple. They do get harder. I have some examples. All right, so this says sine x minus sine x cosine squared x equals sine cubed x. And the first direction, factor sine of x from the two terms. Okay, so again, you'll have multiple choice of what you might see all of these and go, well, which one of these is going to work? Well, that's the one. So I'm going to factor out a sine. And when I do, y'all keep in mind, this is what trips people up when they do this. A couple things. One is if you don't write the x when you're talking about a trig function, you'll get it counted wrong. But if I have two terms here, when I factor out, I have to have two terms inside of my parentheses. So what you want to think about is if I'm factoring out a sine, then I'm dividing this by sine, and I'm dividing this whole thing by sine. So sine divided by sine is 1, and then what's left there is cosine squared x. So I have 1 minus cosine squared x. Next step, apply a Pythagorean identity. So I have a sheet that you will be able to look at when you do these. However, I should have mentioned this earlier. If you haven't done this already, you need to write down those identities in your notes. All of the identities by groups need to be written down in your notes. So apply Pythagorean identity. 1 minus cosine squared. Whenever you see squared with a 1 minus, then it's some type of Pythagorean identity, so you want to look at that group. And 1 minus sine squared, 1 minus cosine squared equals sine squared. And then it just says multiply. Sine times sine squared is sine cubed. So we're done with that one. All right, look at this next one. Probably one of the hardest for people to do because we're having to deal with fractions. But again, it tells you what to do here. So combine using the least common denominator. So you can look at these, y'all. This is a fraction plus a fraction. This is not adding, so I don't need to combine anything. This is clearly more complicated than that. So I have to get a common denominator between these two terms. All right? One has a denominator like that. That's the other denominator. They have nothing in common. So to get a common denominator, I got to multiply top and bottom by sine, and this one by 1 plus cosine. And I hate it, but y'all usually say, well, I just can multiply this times this and that times that. But that's why, because you're getting a common denominator. So on the bottom, when I combine them, I have a common denominator of sine x times 1 plus cosine x. And then I am multiplying this one by the sine of x. And sine x times sine x is sine squared x. And then I'm multiplying this guy by 1 plus cosine x. And that is 1 times 1. FOIL, but it's also a perfect square trinomial, which we're going to do a lot in this section. So you square the first term, which is 1. Multiply them together times 2. And that's 1 times cosine times 2 is 2 cosine x. And then you square the last term. Okay, so I got a common denominator and combined them, and you have to write it all out like that. All right, apply a Pythagorean identity in the numerator. Well, Pythagorean identity deals with squares. So that's a squared term and that's a squared term. And when I combine them, I get 1. So my denominator is not going to change. That's going to be 1. And then I have what I didn't do anything to, which was 1 plus 2 cosine x. Okay. Y'all, when you are working these problems, if you get stuck with anything, please bring me your paper out. Your computer. I'll be happy to help you find it if you haven't asked someone else to help you. Because you can be really close, but if you leave off that x right there, it's going to count it wrong. All right. Next, add the constant terms in the numerator. Well, my constant terms are 1 plus 1. So again, my bottom is not going to change. 1 plus 1 is 2. And then I have plus 2 cosine x. So going on, because I couldn't get it all on one page, factor the numerator and the denominator. Okay? So that's already factored because you don't ever have to multiply out the denominator, y'all. Very, very rarely. Wasting your time if you do. Because it just said you got to factor it back out again. But this can be factored, and there's a common factor of, I hope you can see it, 2. So when I take out a 2, I got to have 2 terms. And let's see, what do I get? 2 divided by 2 is 1. Take the 2 out of here, and I'm left with cosine of x. So that's going to give me 1 plus cosine x. All right, next step, divide out the common factor. So if I divide out the common factor, is that right there? I'm left with 2 over the sine of x. And the reciprocal of the sine is the cosecant. And when I see sine on the bottom, I can bring it on the top and write it as cosecant. And that's what we had on the other side of our identity. Okay. Another one that you will see is a multiple choice problem. So you just have to be able to follow it and figure out which one is the correct answer. So to talk you through until we find the right one, we have the secant minus the cosine all over the sine is equal to the tangent. It's 2 theta every time. We don't have to write it. It's the same. So when you look at this first one, it's a little harder to figure out what you did from here to here. But from here to here, you should be able to see that I have, to get to tangent, I divided this by cosine. Okay? So that means I would have to divide this by cosine and this by cosine. So is secant divided by cosine, does that equal, well, cosine divided by cosine equals 1, but it wouldn't be positive. So there's no way that that can be the answer. All right, so now I'm going to look at this guy, sine, and I have a sine cosine on the bottom. So this time, how did I get there is I multiplied both sides by cosine. I multiplied my denominator by cosine. So that means I would have to multiply this by cosine and this by cosine. So cosine times secant, well, that's equal to 1. We've already talked about that. And cosine times cosine does not equal sine squared. So this one cannot be the answer. So now I'm going to go here again, and this is dividing. It's kind of like they tried to combine these two together, so that doesn't work. So hopefully this is it, but just to show you, okay, again, the denominator they got by multiplying by cosine of 2 theta. And when I multiply each of these by cosine of 2 theta, I do get 1 minus cosine squared of theta. And 1 minus cosine squared of theta equals sine squared of theta. And then if I take out one of these two that are on top and this one on bottom, I'm left with sine of 2 theta over cosine of 2 theta, which is tangent of 2 theta. So my answer is D. So those tend to be more challenging, but it's all there. You just got to see which ones make sense algebraically. Again, putting the pieces of a puzzle together and following steps. All right, the last one. I wanted to do this because I wanted to go over, again, expanding binomials. All right, and we're doing the perfect square. So as I said to you earlier, you square the first term, then you multiply them together times 2, and then you square the last term. And whatever sign, that says minus, so that's going to be minus. If this is plus, then that's going to be plus. But we use this a lot. We're going to keep using it a lot. Okay, so I have 1 minus sine t over 1 plus sine t is equal to secant squared t minus tangent t, quantity squared. Rewrite in terms of sine and cosine inside the parentheses. Okay, so it didn't say change anything, just said change what's inside the parentheses. So I got my parentheses. Secant in terms of sine and cosine is 1 over the cosine. And tangent in terms of sine and cosine is sine over cosine. So now combine and square. So the deal with it is that I have the same denominator of cosine. So when I combine them, I'm going to have a denominator of cosine. And why did I write cosine squared? Because it's not cosine squared, y'all. It's just cosine. My bad. All right. So that's cosine. And when I square out 1 minus sine t, I square the first term, I get 1. Multiply them together times 2. 1 times the sine is sine times 2. So minus 2 sine t. And then I square the last one. Okay? And then it says, rewrite the denominator by applying a Pythagorean identity. Oh, it is supposed to be squared, y'all. You know what happened? Nope, that's what it is. It's because when I square it. All right, having a moment. So it is squared. Now, rewrite the denominator by applying a Pythagorean identity. Means I don't change the top, but Pythagorean identity, cosine squared. Anytime I got a squared, first thing, just squared. If it tells me Pythagorean, I'm going to go look at that group. And cosine squared, if you rearrange it, okay, is 1 minus sine squared t. And now it wants us to factor out the numerator and the denominator. So my denominator, I don't know if you think that's easier, that's the a squared minus b squared. So it's going to be 1 minus sine plus 1 plus sine, 1 minus sine t times 1 plus sine t. And on the top, we just multiply that out. So that's 1 minus sine t quantity squared. So divide out the common factor. Well, I have a 1 minus sine t on the top and the bottom. So when I factor that out, I'm left with 1 minus sine t over 1 plus sine t. And it matches exactly what's on the other side. So I hope you enjoyed that. I love putting puzzles together. Make sure you write down all of the identities that were given to you, 4 different groups, in your notes before you show them to me. Thank you so much for watching, and y'all have a great day.